Well, it was a swell idea until that happened. You see it? Yep. Stripperoo. Strippy doodle. Well, shit. I'll just have to find a replacement. Okay, but to answer the question, does this motor actually work when it is connected to 120 volts? Yes. But it has so much torque that it basically strips the teeth right off of that little phenolic gear. Why would they design? What a stupid design. So those are a couple of clips that I had intended to work into part one, and that somehow got omitted. But so part one didn't explain why the motor conversion wasn't really a success due to those broken gears. And again, you know, the replacement motors for these just seem to be completely unobtainium. So what I ended up coming up with is took some measurements on the motor gear mechanism, and since they're basically AC synchronized motors, I found these guys, and they weren't that expensive, but they're basically, I mean, the same thing in a more modern package. So it'll turn according to the directions I already had a look at. I mean, there's a common, and then this will cause the motor to spin one way, and this will cause the motor to spin the opposite way. So I think that the shaft size is the same here. So what I want to try to do is take this original motor and gear mechanism off this mounting plate. This will slide off, and then mount these guys in there like that. And I think what we'll have are a simplified version of what was on there. So it won't look correct, but who cares? Whatever works here. So that's what I'm going to try to approach next. So what I'm going to try to do, first I'm going to get this motor out of here, modify this plate. But power-wise, I think this is a 120 volt source here. I'm going to have to check it with a meter, but if it is, maybe I can just tap off of these and disconnect the, I think this center switch here controls both these motors in tandem, is what I determined, but get the, disconnect this 50 volts from that, and then just patch in the 120, and then just wire it that way. I'll be able to reuse some of this. Okay, look at this thing, just visually how far this pulley is on the shaft or away from the backing plate. Yeah, no, I think this is going to work great. I mean, let's mount that there. The shaft is just about the right length. It's a little long, but it's all right. It's not going to interfere with anything. So the difference in the shaft here, that's completely cylindrical. This has got a little flat spot on it, so it's a D shaft. And this end is swaged over or something. What I'll probably do is just knock that end out, drill it out, so that this thing will just slide completely through. And then there's a set screw on here. Let's see, yeah, right there. I think it'll be just fine. I'll drop these things in the ultrasonic. These things are only in here for like 3-4 minutes or something. Yeah, it looks a lot better than it did. Heck yeah. Probably clean the rest of the corrosion off of that with some vinegar. But this isn't a 100-point restoration. So... So this is what I've come up with. Where's my other motor? Oh. I mean, check that out. The spacing is almost perfect. And, I mean, there's even a little hole on the end of the shaft there. I guess I'll have to show you on another motor, but that set screw went right into it. And I think that, again, the spacing is just excellent. So I did have to that collar down there at the it's like the shaft bushing. It sticks up. You can see just a hair. So what I had to do was goes on this side, just sort of waller out the hole a little bit, and it fits flush up against the plate just fine. Get this thing right about where I want it here. It's about right. And I've got a spring-loaded punch here. Just punch new holes and drill those. Now look at that, folks. You just can't ask for anything better for an off-the-shelf part. This motor pretty much mounted up to this mounting plate with very little modification, and even the little hole in the, you can see in the other one, it's already got a pre-drilled hole there. All I did was slip the pulley on there, and the set screw centered right in that hole, and I mean, I can tell it's lined up just because of the, you know, the location of the switch stacks. Right there. Right there. Done. Off-the-shelf part from Amazon. Okay, both of the motors are in. I mean, check that out. I mean, that is buttock to spec right there. I mean, there's just... I think this is gonna work great. Now just to wire the thing, I'm gonna disconnect, this is the 50 volts here. Oh, maybe it just disconnected itself. Yes, it did. These two wires go here and here, so what I'll have to do is run 120 volt switched mains in one side to common, run one to the other motor, and then the other side here to the switch. And these wires will do the rest. Should work then. Okay, I got it. Except for one thing. Works great on 240 volts. The motors are rated at 120 volts, but as soon as I connected everything and got it attached, I found that the motors didn't have enough starting torque in order to start moving the mechanism. If you reached over and kind of turned it a little bit to give it some help, then it would go, and it would just keep going until you let go of the relay. So you remember that step-up transformer I bought? Well, I'm glad I bought it, because turns out it works great for this. So again, although these motors aren't rated for 120 volt or 240 volts, I figure giving them that little extra oomph gets them to go, and they're just being used intermittently. So I mean, you should still get a decent amount of life out of them. Absolutely zero complaints there. Oh, unfortunately, I did break off the little switch that's the triggers the relay hold, so it won't really work without that. You have to manually hold this relay in, so have to fix that. But other than that, I would call it a success. Now, so that's what I've done temporarily. I just patched into the switched mains power here, and that thing is stepping it up to 240, but it works. So I'm gonna just incorporate that somewhere into this box here and call it good.